So really quickly, I do want to point out, I know on number one, a lot of us try to use what method here? On number one. We use the quadratic formula, totally fine. Remember, because math, or Delta Math is going to ask about this, they asked about the master product. What was the master product again?
A times C.
A times C. So that's 4 times negative 27, negative 108. Okay? If there are factors of negative 108 that add up to 12, then I can actually factor this one. It's not the easiest thing to find sometimes, but if you are slow and methodical and take the time, 2 times 54 is negative 108. But is that going to add up to 12? No, definitely not. That's 52. Please grab a calculator. What's 108 divided by 3? Calculator in hand. Just don't make it harder than that has to be. 108 divided by 3. What is it? 36. Okay. So notice I'm just using the calculator to my advantage. Does that add up to 12? No. Can you take 108 and divide it by 4?
Sure you can.
27. Is that going to add up to 12? No. Notice that's 23 though. I'm getting closer and closer to this. Can you divide 108 by 5?
No.
No? Like if you try it, I mean you can try it, but the reality is it's not a multiple of 5. But if you type it in, you'll get a fraction. Can't do it. Okay, so what is 108 divided by 6? 18. Does that add up to 12? Guys, remember, if there are factors of A times C that add up to B, what method can you use? You can factor it. Hey guys, at least for me personally, I would have done a factoring method here. Quadratic formula, sure. I'm going to talk about 2 things with it, but I'm using this factoring method, 4x squared, negative 27, negative 6x, and 18x. Okay, what do 4 and 18 have in common? The greatest common factor? What do 4 and 18 have in common? The greatest common factor? They both have what? A 2. Does anyone, by the way, remember how I taught you to use the calculator to find the greatest common factor? Kinda. This might be helpful for your test that you have coming up. Everybody grab a calculator. Man, the laziness is astounding.
Yeah, Mr. King, he was right there. Parker right there.
No, not you.
Oh.
These 2. You're right. Your partner is right there. That's logical. The I don't want to walk 5 feet is nuts. I'll run up and down a court.
About 8.
John won one
It's
too.
called a hyperbole, but thank you.
English.
You wanted that in your English class? Good. Fine. Alright. Hey, so what's the button that's going to let me do full prep? Menu. Okay, so hit menu for me. We're trying to do something with numbers, right?
2.
So numbers, yep, 2. Does anyone see anything there that lets
5.
you, that's connected to a greatest common factor? Greatest common divisor? Is that the one you selected? So select greatest common divisor. Put a 4, a comma, and an 18. Mr. Anderson, if you want to walk around and make sure that they're good with that.
I've actually
The 18, right? The 18 is up there. Greatest common divisor is 2, right?
No, it says 2 minutes. It says 2 few arguments. I put a comma.
Wait, what do we have?
Did you put 4x squared in 2? No, not parentheses. Just 4 and 18.
18.
Yep. Okay. 4, comma, 18. Okay? So guys, please take advantage of this. Anybody else not get the 2 by doing that method? Okay, use the calculator. What's the greatest common divisor of negative 6 and negative 27? Yep. And by the way, don't forget it's a 2x, right? They both also have an x.
You said what?
Greatest common divisor of negative 6 and negative 27.
3.
3. Now notice they're both negative, so I need a...
Oh.
They're both negative, so I'm going to factor out a negative here. Okay? What about 4 and negative 6? greatest common divisor of 4 and negative 6.
2.
Notice you can just use the calculator to do this for you.
You said
Now
4
is
and
this
negative
4 and negative 6?
2,
2. Now am I just factoring out a 2 here?
2x.
A 2x? And then here, 18 and negative 27. Greatest common divisor.
9. 9.
No.
9.
Can't divide negative 27 by 18, but you can divide both of these by a 9. There's my factored form. And remember, if you've got a factored form equal to 0, what you're going to use?
The 0 product.
I'm going to use that zero product property. So that's the personal strategy I would have gone with. But hey, can you use quadratic formula? Yes. But remember, John, you need to be able to show me that you can do multiple methods. Okay? All right. But yes, you need at least one method that you can consistently go back to. Quadratic formula, if that's it, you're good. If you worked this out using the quadratic formula,
Plus 3.
you should have gotten x equals 3 halves and x equals negative 9 halves, which is what I saw around the room a lot, okay? One thing I want to caution, because I saw a group do this, and super common mistake. So first off, they did a great radicand here, which that radicand in that quadratic formula is the discriminant. Oh, before that even. Guys, please make sure you put your plus or minus. If you don't put plus or minus here, what are you actually doing but with the negative b in the square root? Multiplying. Are we supposed to be multiplying those things?
No.
Nope. You're adding and subtracting that discriminant. So, or the square root. So b squared minus 4ac, substituted in really well, got the 576. But then, in the calculator, they type square root of 576 and you got what? 24. But they left the square root there. Very common mistake. Please understand. Super common mistake. But you already took the square root, didn't you? So do you still write the square root? No. Guys, once you take the square root of 576, you've already taken the square root. Don't write the square root there. Great job here. Negative 12 plus 24 is 12. 12 divided by 8 is 3 halves. Only thing I will say, ooh, I should have noticed this from the beginning. Remember, the whole point is that we're solving for x. So really, this is the quadratic formula, x equals. We're finding our zeros, finding our roots. Don't forget that, okay? Questions, comments, concerns? Kenny, we did 4 of the 5 questions yesterday.
He's still on his
No, he might like it.
We did do 4 of them, didn't we?
We did the first
It's
2.
good.
You said we going over the rest tomorrow.
No, we
I think we did the fourth one too. I think.
We did 1, 2, and 4. We did not do 3 and 5? Okay. So we did 3 of them. Yes, I was planning on going over the last one. I thought it was only 1. Alright, number 2 though, before that, square root of negative 20. Remember, if I want to take a square root, I don't just want a decimal. I need to find factors that are what? Perfect squares, okay? So, what's a factor of 20 that's a perfect square?
4.
4. 4 times what? 5. Notice that's only a positive 20. I still need a negative 20, right? So what do I still need to multiply it by?
Negative 1.
Okay. Notice, guys, I have written this into a factored form. I've written it as 4 times 5 for my 20. I wrote the negative 1 separately, and I'm going to show why in just a second.
Negative 1 from the I?
Well, it's not from the I. I don't have the I
It
yet.
is the I.
But it's going to get us to the I, because be careful. Remember, I is not negative 1. Remember, I squared is negative 1. What is I?
0. I mean, it's imaginary. A 0. Negative 1. Square. Yeah,
Root of
Mr.
negative
King,
1.
why didn't you?
Yes, it's imaginary, but square root of negative 1. Yes, ma'am.
Why didn't you just do negative 4 times 5 and then give you negative 20?
It does, but here, so it's coming back to this idea of I. So if you do negative 4, you don't actually, it's going to be an imaginary number anyways. I factored out that negative 1 separately, and here's why. So let me get to this next step. Remember, I showed you all this property yesterday, and it ties back into exponent properties, but how many radicals can I rewrite this as?
3.
I can rewrite it as 3 radicals. What are the 3 radicals?
Square root of 4, square root of 5, square root of negative 1.
Right there. Grounded, that's why. I wrote the -1 separately, because what's the square root of -1? We gotta know square root of -1 is I. 2 root 5, because there's the square root of 4 is 2. That's irrational, so I leave it, times I. Okay? So 2 square root of 5 times I is the answer there.
What is log? Yesterday was on the
What
board.
y'all looking at? Y'all so
Log.
Log, that's
We were asking
a
about before.
concept that we're supposed to get to, we probably won't though, definitely not to the level that was doing that with me
You
all.
see where Richard Kenny got it from?
Okay. Alright, what do we get for our last one here? What do we need to remember? First off, 4 minus 5i, how many numbers is that?
What is
One.
That's one number,
The 5 is imaginary.
because the 5 is imaginary. Remember, there's a real part and an imaginary part. Remember, a plus bi is really just one number. Okay? So what do we get when we subtract these two complex numbers?
2.
Where'd you get 2 from?
4 minus 2.
Okay, so notice it's 4 minus 2. I grouped my real parts together. Then what?
You group your imaginary numbers.
Then I group my imaginary numbers together. So minus 5i.
Minus 3i.
Is it minus 3i?
No.
No.
This is right there. This is minus 5i.
Minus,
Negative 1.
not negative
Oh,
1.
hey.
Minus what? Minus negative 3i. Be careful with that. You need to recognize that you're subtracting a negative 3i. So what is 4 minus 2? 2. And so ignore the I for a second. What's negative 5 plus 3? Because notice I did make that minus a negative a plus. Negative 5 plus 3 is negative 2. So it'd be minus 2i. Remember, the big thing there is, can you add the real and the imaginary parts and put them together? No. Real go with real, imaginary go with imaginary.
They go fake.
What?
I don't know. Look,
It's not fake.
I don't have.
Alright, so let's continue with today. Any questions around this before we do some more stuff with some imaginary numbers today?
No, I don't like imaginary numbers.
You do or do not?
Not.
Why not? Huh? Why are you gonna steal my phone? Dog, how are you gonna steal my phone like that?
Yeah, one.
Come on, man. Yeah, what's
Alright, so, agenda for today. We're gonna keep working with some imaginary numbers. I do want to pause and point this out. They're really called complex numbers, okay? Because there's a real part, and then there is an imaginary part. So if it was just 3i, I would call that imaginary, okay? But if I have a real part with it, we call it complex. Technically, all real numbers and all imaginary numbers are complex numbers together. Because the number 5, that's real, right? But I could write that with plus 0i. Because if I have 0 i's, that's really just 0. So all real numbers are just a special type of complex numbers. 3i, what's the real part of it? Or typically we put the real part first, but notice that imaginary number is also a complex number. So every number that we have studied is complex. There's nothing other than complex, is there?
I don't think so.
I didn't think so either.
Well, because every number is pretty much complex. Like you said, basically.
I don't think we've discovered a number besides the complex number system yet.
Probably.
I'm gonna say that. Anyways, it's a complex number. There's the real part to, or the real part to it and the imaginary part to it. Okay. Yeah. So remember all of this. We're gonna do some review with all this tomorrow as a review game. We'll probably bring back the Harold and Moats. Yeah.
As you do.
Okay, so you need to make sure you learn as much as possible today so you can prepare for that review tomorrow. Today we're going to focus on these ideas of the complex numbers. I will say we're not going to get to the complex coordinate plane more than likely, so don't sweat that. But we do need to know how to add, subtract, and multiply imaginary numbers. And we need to simplify square roots with imaginary numbers. And solve quadratics with imaginary roots, okay? So, Remember, we talked about this yesterday. What's the whole point of the imaginary numbers again? What's the whole point of imaginaries?
-1.
Something with a -1-ish.
Oh, it's negative numbers. Negative.
So-
Oh, I got notes. Let me go.
I will say this.
Oh, it's great. It's negative numbers. It's anything that's, I think, negative. It's better or less than negative
Okay.
numbers, something like that.
So, let me say this.
I know what.
Hey, please, slow down, listen. I is the square root of -1, but that's actually not the point. The point was, when I square I, what do I get?
Negative,
A positive.
negative.
I get a -1.
-1.
Remember, this is Finney what you're trying to go to. Any real number squared gives me a what? A positive. But now I have a number so that when I square it, I get a negative. So like right here, this is 3i times 3i. That is 3i squared, isn't it?
Yep.
So what do I get? Not a +9, but a -9. The whole point of the imaginary numbers is so that now I can square something and get a negative. Now I can square something and get a negative. Here, that's going to be -2. Because I squared an imaginary, and then the square root of 2 squared is just 2. Okay? The whole point of the imaginaries is so that I can square and get a negative. Adding and subtracting. You add real with
Imaginary. Real.
reals, and imaginary with imaginaries. Think of it like terms. Because really what we're saying here is this. I'm going to point this out. This is saying that I'm adding I how many times?
2,
2 times. Here, I'm taking away I how many times?
5.
Notice I can't put real with that. I'm taking away I 5 times. So these would cancel, leave me with 0. And so I have -3i. That's why 2i minus 5i is -3i. Okay? But real with reals, imaginary with imaginaries. And then I think we did 9a at the end, so we didn't do 9b yet. I asked you to do 9b for homework. Did anybody actually do that practice question?
No, I did Delta now.
Okay. Alright, how did we approach multiplying here in 9a? Anyone remember?
Do the real numbers first.
Not when we multiply. Remember, we're not adding and subtracting here. We are
Multiply.
multiplying. What did we use?
Square root.
Boy, you stole my pencil.
Hey guys, if this was 3 plus 2x times 5 plus 7x, how would you multiply to get to standard form?
Distribute.
This one has nothing to do with this, but can I have a pencil?
Hold on. Distribute using, what did I recommend? To help you distribute.
PIMDOTs. You wrote 1, 2, 3, and 4. That's what you did first, second, third, and fourth. I know.
Say again. Oh yeah, the area model. Hey guys, what helps me go from a factored form to a standard form?
Area model.
Area model. What helps me go from a standard to a factored? Area model. Guys, if I'm trying to multiply this, guys, we need to recognize, hey, right here, John, Finney, if I ask you on your test to go from this factored form to standard form, you need to immediately think distribute. And I recommend the area model with distributing. Here is the same thing. 3 plus 2i, 5 plus 7i. What's 5 times 3?
15.
What's 5 times 2i?
10.
What's 7i times 3?
21.
21i. And what is 7i times 2i?
14i squared.
14i squared. Now, we need to remember the whole point of I squared is that we now get a, what kind of number? A negative.
Why do
So
we put square?
15 plus 10i plus 21i plus actually a negative 14. The whole point of I squared is now I get a negative. So what can I add together? So notice all I did was I took my different terms, I'm adding them. Negative 14. So what do I get? Is there anything that can go with the 15?
Negative 14.
The negative 14. Notice it was originally I squared, but I need to simplify it. So 15 minus 14 is?
1.
And what's 10i plus 21i?
31.
I squared.
Not I squared. Remember, you get I
Oh,
squared.
wait.
Don't be disrespectful. I squared is when you're multiplying the i's. Okay? When you multiply the i's is when you get I squared. Okay? I need you to work with your small group on B. So let's get up to our vertical surfaces. Let's work on B.
I want to help
I'm
guys.
going to say 3 to 4 minutes, and we're going to come back and talk about it. Mr. Anderson and I will be there to support. Mr. Anderson, do you see why I don't recommend the just like pulling?
No, do 10 times.
Erased it all.
10 times negative 6.
There.
60.
But- So this is a plus.
Yeah.
So technically this is.
Negative 60.
But.
Alright. If I get eyes and ears, please. Vinny, how did you end up at the
Parker, you make me
Alright, hey guys, Aces right here.
Can I have a pencil?
Mr. Anderson, I grab their attention real quick.
I got you.
Alright guys, hey, Jaden, just really quickly, okay, before we move to the next thing. Again, just write out your factors, just like we did with the area model and quadratics, right? And just follow the math. What's 4 times 10? 40.
25.
What's 4 times negative 3i? Negative 12i. What's negative 6i? And again, I will point this out. I put my negative here. Like if it's a plus, I don't sweat it. But if I have a negative going up and down, I put my negative with here so that I don't forget that negative when I distribute. Okay? I saw several of us that forgot that negative when we distributed. What's negative 6i times a positive 10?
Negative 60i.
Negative 60i.
Now, what's a negative 6i times a negative 3i?
18i squared.
Plus a positive 18i squared. Okay? Now, that gives me 40 minus 12i minus 60i plus, what am I going to write instead of 18i squared? Remember, the whole point of 18i squared is that now I'm getting a negative, right? Not a positive 18 anymore, a negative 18. That's what we would want here, okay? Now, put your real parts together. 40, what's happening to 40? Okay, so 40 plus a negative 18, which is the same as 40 minus 18, which is? 40 minus 18?
40 minus 18, 22.
And then negative 12i minus 60i, by the way, you got calculators. Negative 12 minus 60 is? Negative 72i. That's my number. Okay? Nines, really quickly. Walter, Dean. I'm not going to stress it a ton, but I will point out the real part is supposed to go first. So, Walter, stop being disrespectful in my class. Just be aware, guys, the real part traditionally does come first. Is it the same number? Yes. But we traditionally put our real part first. Okay? Alright. Questions about part B here?
No!
That was a thing. That was a choice. Okay. Please notice, this is the next question. By the way, let's just pause for a second. Please get this open up resources task out. This was with the mathematic thing. Go ahead and get this out so you can write this down if you don't already have it out. And then we're gonna, once you have it written down, I want you to work on 10A and 10B. About the,
I forgot I had some slaves.
Jaden, do you have this paper out? You got it on Wednesday. Or on Monday. Okay. No. Alright.
You're weird. No, Walker, you like that dude on Scooby-Doo.
What's negative 2i?
Jackie.
Negative 8i. Negative 2i. Negative 4, but you have I times I, so
Yeah.
oh, take that word, so 16.
I know you ain't drinking that because I'm drinking.
Minus 8i.
Who drinking?
So then what should?
Why people like that dude? Why people like that dude outside?
Alright, ladies and gents, let's talk
Your
about
hair is so cute.
I was trying to get a percent. Yeah.
Hey, James, that's not in your group, and don't touch people like that, especially one of my female students. It's inappropriate. Don't do it. We clear? You need to make smarter decisions.
I see y'all.
Okay.
I wish I could read this class.
Okay. Right here, 10A. Remember, we're going to multiply. Did you just sit on your iPad rather than math today?
Yes.
Yes, you did. Get up to the board and let's work on that math question.
What math question is it again?
Number 11.
You pay attention to the name.
Have the paper. You use whatever method you
I
want.
wish I could just hair. I was used to give somebody hair.
Hey, John, Ivy, don't do some phenomenal math over there.
Parker.
You ain't doing crap.
See?
She even said sure, as in we don't both know she's lying to cover you.
Always say sure.
Okay.
I always say sure.
Solving.
I'm like,
I'm
what's one
about to
plus?
put you in a different group until you get your crap together.
She gonna say sure.
She just said
Do something.
Given the function f of r equals r squared plus 4x plus 5.
Actually, this we don't finish it. We want to
Five r
She was with us. We all have.
You guys know distance? Because I was recommending that.
somebody was
Oh, because she had her own.
Remember, that was the distance from the line of symmetry to either of the roots.
They didn't know it.
If you want to use quadratic, you can. I'll show you why I would give that one in a second. Okay? Yes, it says solve them, find the roots.
Yes, sir.
It's the young version for the teacher. My bad. I'll take it out of the video.
Thanks. What method y'all kind of use?
no, go up a little bit.
Brianna, wait on me.
Jaden, you should already be started. We're 2 minutes in.
Sanitize
I
it, you
lied,
know?
3 minutes.
I don't want to touch the expo.
It took you 3 minutes to sanitize.
No, I have big glass. Y'all ready to graduate?
So what's up in my egg?
Opposite of B, divided by 2A.
Crap. Remember when we think back to the.
Hey, Brianna, can I get some help?
I'm doing it on my paper.
Can you help me?
I'm doing it on my paper. Leave me alone.
Ben.
My head.
Not that important.
You got blood on me.
What are our factors?
Yes.
2 minus 4. That ain't right.
Right, so I guess take the, they can do it at their word, plus or minus -1, right? Times the square root.
I said no.
My head. I
And
said
that's
real.
where -1 becomes.
My head is itching.
But then we're still left with the square root 2, right? And we don't have I squared, we can only have I.
Yep.
Well, we're just multiplying these. Remember, the square root of -1 is just
Why is it not right?
by square is -1 because I multiply that, so that is why this goes right times. Remember that other one we had 2 by times 4 divided.
Side of the classes again, or like this?
Yeah.
So that's how we write our solution.
Just the radical.
You know.
Bro, we need to do that telescope shit, bro. That's all. Until JT big the telescope.
Mr. Kenny, I have a quick question.
Yes, ma'am.
Okay, I put in 16 minus, well, I put it in as 16 minus 4 and get that answer then divided by 2, or do I go ahead and put the whole thing in?
Remember, this whole numerator is grouped together. So you need to do everything in the numerator first.
Yeah, we're K.
That's why you got the real, because the square, you remember what the square root was, right? The square root of negative.
There should be -2 squared is positive square root of 4 minus 4 plus 5.
So I can rewrite square root of 4 times square root of negative 1.
Oh wait, was there -2? No, it was just a 1.
What's square root of negative 1?
You were substituting it, we're not taking it out.
Whole point. Okay. And I can now divide everything by 2. -4. I am literally dividing everything by 2. It's -4 divided by 2.
4 divided by 2.
2 divided by 2 is 1, so it's plus or minus. But notice, if you put the square root in there, you're gonna get non-real calculations. That's why I always say just do the radicand, just the other thing, the thing under the radicand. Okay?
I'm confused, Mr. Kenny.
Yes, Brianna. Good overall and simplifying. A word of caution here though. Make sure that you put this fraction bar all the way.
Why do you have 16 minus 20?
4 squared is 16. 4 times 1 times 5 is 20. I would have personally just put
That's
all
negative
of this into the calculator. What is 16 minus 20? Yeah, y'all didn't do different things. So, good job on recognizing plus minus 2i. But what you can now do is distribute that division. -4 divided by 2 is -2. 2 divided by 2 is 1. That's what it says. Solve it. You see it now? Okay.
It says.
Okay. Hey.
Well, we just did the x intercept.
-4.
So I squared is -1, but do you have I squared here? So what you
Well, get the
actually
fuck out
want
the
to
way.
do to simplify is you can distribute that division by 2. And then -4 divided by 2 is -2.
Why you got an eye?
And then 2 divided by 2 is plus.
I also do an offset.
And you get the same thing right here, so it'd be plus or minus.
Divided by 2. Can we divide it?
Stop talking about it before I get angry. And I'm gonna crank.
So let's simplify it first.
Get him over.
Really fast, right?
So now, is that a perfect
Plus or
square?
minus.
It is, right?
That's your question.
Squared.
So it would be,
Minus, what is C?
that would be squared.
Divided by
It's a negative, so it has to have
I.
But what's my perfect
Let's
square?
type that radicand. That's me.
So what would it be?
Yes, ma'am.
Because y'all won't leave me alone.
Right, we can't square I inside this.
Leave me
Just
alone.
one I. But we simplify this before we divide. We can't divide.
Or I can step back in the way one more time.
But when we have a.
I erased that bit. I bet you want.
That square
You?
is 2.
You ain't like that. Bree gonna get on your ass. That's why you don't want to do it. Do it if you bad, nigga.
Real number. I squared is
You blow.
But we want this like.
Stop.
If we wrote 2I squared, that would be real. So it
Because
would
remember, the idea of a square root
also
is
make
in
sure it goes next to
the past, like before you number I, any number.
Agree, we on 11.
When it was like.
But now, I have a square root.
And I'm good.
All right, Bob.
The whole point of the imaginary number is now I can square something.
Man, I ain't worried about it.
Okay.
We
Alright.
probably doing the other one.
Once you finish that, but let's go ahead and talk through this one
Hey,
too.
I
Really
did
quickly,
On the board,
Okay.
all of it.
I want to point out on
tell by the
this
handwriting.
problem,
Oh,
some
yeah?
of us, if you look around the room.
You were
Mr.
using
Anderson,
purple
can-
marker?
Hey, Mr. Anderson.
Oh, no, the
Can you
black.
start
The
the
black.
camera if it's not already rolling?
Oh, no, it's on.
It's rolling.
Is it rolling?
Action.
It's right.
Eyes and ears,
Yes.
please.
Action.
Okay. Some of us use the quadratic formula. I talked to a handful of us that heard my recommendation, and we use the distance method. Okay. No matter what answer did you get by the end? Negative 2 plus or minus 1. Not 1. I. Okay. So here's a couple of details I want to point out. Remember. Yes, sir. Yes.
Perfection. Hola.
I'll do it today.
I wish I could have that iPad.
Perfect.
You too, man.
All right.
Have a great one.
Everybody go through your iPad.
Eyes and ears, right here. Okay, I just want to emphasize this. So, if, what?
Like, make something more apparent, I guess?
Yeah,
Yeah,
like,
so, like,
show how important it is.
Yeah.
Yes, sir.
Yeah.
Yes, sir.
Okay,
said empathize?
I get it.
if you did the quadratic formula, nope, was it, yeah, -4. So if you did the quadratic formula, you got to this point somewhere, right?
Somewhat.
Yep, somewhat. And this is why I don't like the quadratic formula. If you use the quadratic formula, you have to do more work than if you used another method, okay? Sometimes quadratic formula is really the only one you want to do. But guys, if you can get a nice value for h, an integer value for h, using the distance method is great. Here you have to recognize what is another way to write the square root of -4. So we have to recognize that. Square root of a -4. So you would want to rewrite that as square root of 4 times the square root of -1.
One.
What's square root of 4?
2.
My iPad died.
And then what's the square root of -1? I. Remember that's the definition of I. Now I have to again simplify because I can
Yeah. Oh.
and divide by 2. And so if you use the quadratic formula, you just have to do a whole lot of simplifying, okay? But if you use the distance method, h plus or minus square root of h squared minus c divided by a, h is -2, plus or minus -2 squared. What is -2 squared? 4. Minus 5 is -1. And hey, what's the square root of -1? So this group and the group over here, they got to that without doing a whole lot of extra work.
What about me, bro?
Guys, if you did that approach, then yeah. Guys, if you can use that distance method, it's way more efficient. Once again, if you can use the distance method to solve your quadratics, way more efficient. Now, I did one final way right here. What did I do?
Wait.
So,
Vertex?
yeah, I converted this to vertex form. I didn't think anybody would go this route, and I totally get if you don't want to go this route, but you'll notice I found my h, I substituted h in to get my k, so my a was 1, x minus h plus k. I solved it, took my square root, and did I get the same answer that everybody else did?
yes.
-2 plus or minus I. I don't want to just say, hey, do this every time, because I want you to have flexibility and options and to find what works the best for you. But I will point out, if h is an integer, it's probably a great idea to use the distance method or the vertex form. It's going to be simpler. It's going to have less work at the end. If you don't get a nice h, like if I got h equals 3/2, I'm not using the distance or the vertex method. I'm going to use the quadratic formula, because I probably won't have to simplify a whole lot. But if you get a nice integer value for h, I would use that. Okay?
Sir.
I'll bring this back up in a second. I just want to build on this quickly and look here. So check one of our solutions. We didn't take the time, but if I put, say, -2 plus I into the calculator, it should make the equation what? It should make it true. I'll show you how to do that in a second. Are these solutions going to be x-intercepts? Are these solutions going to be x-intercepts?
No.
Yes? Leah thinks yes?
No.
No? Why do you think no? We're just throwing stuff out there to be contradictory towards Malia? Okay, how can we check ourselves? We actually found a way using the discriminant. Mr. Anderson taught that lesson, but how could I check to see if it's going to give me x-intercepts? I could graph it, right? Thank you. Part of your test, you're going to have a graphing calculator.
You want to do that 2-page stuff again?
Yep. What was the original equation? X squared. Was it plus 4x?
Plus 4, plus
Plus-
5.
Plus 5. Does it have x-intercepts? No. There's no x-intercepts. Hey guys, why doesn't it have x-intercepts?
I don't know.
Because it has what? Imaginary roots. Guys, the zeros or my roots are what? Imaginary. Guys, you only have x-intercepts when the roots or the zeros are real. Let me emphasize that again. You're only going to have x-intercepts when those zeros are real. Guys, on this graph, do you see an I anywhere on that graph?
No.
So are you going to see those imaginary roots? Say again. So it is no there, okay?
Yes.
So, please write down actually pause on writing down that work. I do want to show you one last thing. Remember we said that if we substitute that value into the equation, the -2 plus I, it should make the equation what? True, okay? So, you will be able to do this. We may not remember it, but I'm going to show you this to you anyways. X squared plus 4x plus 5 equals 0. That's where we started, right? And what did we come up with for x? -2 plus I. Okay? Put parentheses right here. Okay, so -2. Now please pay attention to this. There is a letter I down here, but that's a variable. If you actually go to the pi symbol here, what do you see next to pi? You see how it's a funky looking I? That's the number I. Not the letter I, that's the number I. So put -2 plus I in. Here for this x,
What did you press?
the pi symbol, just like I said. So down here in the bottom left, see my cursor?
Yep.
Bottom left, near that where that pi is, there's I. What's -2 plus I? What's it say?
True.
Which means those are my solutions, because what do solutions do? Make the equation true. Don't forget, guys, you're going to have a graphing calculator. You can check your roots on the x-axis as long as they're real. If they're imaginary, you can always substitute them in and see if it makes the equation true. Notice I can make this a minus as well. There you go. If on the test you're on that calculator portion and you don't just, you know what you want to do but you can't remember how to plug it in, I will be okay telling you how to plug it in, but you have to tell me and show me that you understand the math behind it before I give this to you. Okay?
Where is it straight up solution?
That.
So just write that in.
Well, because how do we check solutions? It should make the equation true, right?
When is
It made the equations true Friday. So we're doing that review game tomorrow.
The one that we did before?
Yeah.
Tickets and stuff? How much would
Not
that
all
be
tickets.
for,
Wait, we doing the tower taking?
Yeah.
Gold?
The castle and notes with the gold.
Bet.
I hope I'm in the right group.
Where you on up?
Huh?
Where you at?
How much would that be
Niggas, you right?
for a grade?
It'll be a decent bit, but it always works out so that the minor grades, which include
Mr. Anderson, you gonna be here tomorrow?
and
No.
tax
No,
population comes out
Last
to be
day.
10 to 20%, and then your tests are double that. So overall 20%.
Huh?
To not,
Yeah, probably not.
for full credit. We can do it later, but the
Wherever
test
they
is
send you.
Friday, I want it done
Yeah,
tonight.
pretty much.
All right,
Well, yeah, I definitely will be here next.
so Does anybody else feel like we need a little bit of practice rewriting using the number I?
No. Nah, we good.
Can I just get a quick thumbs up if you're feeling good about rewriting using I? Side if you're not sure, thumbs down if you need help with writing with the number I. Got sideways, but no downs. Okay, so I have these sheets, I'll get Mr. Anderson to help me pass these out. Instead of doing all 4 of them, since we're feeling pretty okay, I want y'all to just do C and D, so when I pass the sheet out, you'll have it, but I want you to work on just rewriting C and D with the number I, okay? So you don't have this sheet yet, Mr. Anderson and I will pass it out. They're right here. The learning.
That's a big taste.
Eyes and ears. Okay. Remember, hey, when I'm trying to simplify a square root, I need what kind of factors?
Positive squares.
I need perfect squares. So, 25 times 2, that's 50, isn't it? Times -1. Notice, I'm not just doing one piece of it, guys. I'm keeping the whole number together, simplifying what I can. Square root of 25 times square root of 2 times square root of -1.
It's high. With the high of.
What's square root of 25? 5, okay? What's square root of 2? It's irrational. It's a nasty little decimal, so I'm going to leave it as square root of 2. What's square root of -1? That's it. Done.
745.
Keep it all together. Okay? Over here. Right? 6 minus, rewrite your -8. 4 is a perfect square. Times 2 times -1. 6 minus the square root of 4, square root of 2, and I would, you can write it as the I if you want, I just like to stay consistent, square root of -1. What's square root of 4? 2. What's square root of 2?
Irrational.
So square root of 2, square root of -1 is I. Now, here I will point out, you can actually divide everything by 2. The final answer that you ideally want here is
registration and payment are due by this Friday, November the 21st. Trees will be set on Gilchrist High School football field.
3 minus root 2I.
Concrete.
That's the ideal answer you want there. Guys, yeah, that's the ideal one. I would accept here, it's definitely evidence of understanding. Please do not forget that this unit started with all the forms of quadratics. Looking at vertex form and knowing the vertex, the line of symmetry, and the concavity. That will be on the review tomorrow. It'll be on your test on Friday. It had looking at factored form and knowing the roots and the concavity and sketching from there. But you can also identify the line of symmetry and the vertex. Go back to the beginning of this unit. There's been 3 proficiency scales. The first one was all about quadratics. It's also being able to recognize a parabola in a table and in a graph and in an equation. Part of the review tomorrow will literally have you looking at those details, making sure that you can identify when it's quadratic or when it's linear or exponential. So prepare for that review.
Sorry,
All right.
Sure.
That's all I got. Go ahead and pack up.
Like, we're trying to drink after y'all partner.
Yeah, I was about to ask.
Yeah.